So today I need you to go into Google Classroom and find 4.6. It'll either say Wednesdays or Wednesday, Thursdays Jamboard notes. So it's the last Jamboard that we were working on. Get into that Jamboard, and the last thing we left off on was slide 6. So if you want to see some answers for that, to see how you did, I believe all our classes got 26 for number 1, and then we got 9.2 for number 2. And 9.2 was a rounded answer. So I tried to stress to you that it is not good to use rounded answers in another problem. So we try to avoid any rounded answers when we do these other two problems. So the way to set these up, I'm not going to actually finish them, but you should be able to do it once you've got it set up. So to find HL, you could have used Pythagorean theorem, but because you rounded 9.2, it would not be a good idea to use Pythagorean theorem. So it'd be better to use a proportion. So what I did was I said x is to 24, so that's where these two numbers came from, as 24 is to 26. So that's how this side was set up. So then you would cross multiply, you would get 26x equals 24 times 24, whatever that is, and then divide that by 26. So on number 4, to find LK, so I called it B. You can't see it, but I called LK a B. So then, again, you don't want to use the 9.2. So you could say B is to 10. So start here and go here. And then come up to this one and say as 10 is to 26. So B is to 10 as 10 is to 26. So that's how we set it up. Cross multiply, you get 26B equals 100, and then divide 100 by 26 to get that answer. So this next page, you are practicing, and I know I cut off this with this recording, but what you are trying to do is see how the left side or the right side is set up, depending on where the blank is. So see how this side is set up, and then according to the way this side is set up, then you want to be able to fill in this blank. So, for instance, HJ is to HL. So I see an HJ here and an HL here. I also see an HJ here. So you kind of have to look at the other letter, JK. So JK is over here. So it would seem like if you go HJ is to HL as JK is to LJ. So you could come over here and put LJ. So that's how you're going to do these problems. So I want you to stop the video, fill in this blank, this one, and this one. Don't take forever to do it, and then come back and I will give you the answers so you can check yourself in just a second. So go ahead and go try it first. So now you can check your answers. So the red letters are the ones that you were supposed to fill in. So check that out and see if you were able to find the correct answers. Now there's something I want you to notice. A lot of these across from each other, these diagonals are the same. Even though this says LJ and this is JL, it's the same side. JL and LJ are the same side. I see those across from each other. JK is across from JK. JH is across from HJ. So notice how often that happens. So go ahead and check your answers real quick. So that's leading up to something. I want you to take note of this first part here. Let me move that out of the way. It says, look at problems 2, 3, and 4, the ones from the previous page, 2, 3, and 4. Each problem has a side diagonally from itself. So remember I was telling you, JL and LJ are the same. For instance, in problem 2, HL over LJ equals JL over LK. This type of problem is called a geometric mean. LJ is the geometric mean for HL and LK. So think about at the beginning of class when we were finding the geometric mean of two numbers, we multiplied those two numbers and then we would square root them. Well, that's what would happen here, because when you multiply these two numbers, they are the same thing. Okay, so when you multiply those two numbers, and then you'd have to multiply these two numbers, what's going to end up happening is the answer, well, these are the geometric mean of these two things, because you could replace these with an x. So let's say that's x times x. So that would be x squared. So x squared would equal whatever HL times LK is. So whatever that number is, you would have an x squared equals that number. Well, to get rid of the square, you would have to square root. So it's the same process as a geometric mean. It says if you look back at the original right triangle, LJ, so where is LJ? It's right here. LJ is the altitude. HL is a segment along the original hypotenuse, and LK is another segment along the hypotenuse. So this altitude caused this whole hypotenuse to be cut up into two little segments. So I call one of them segment 1 and the other one segment 2. So instead of redrawing all of those pictures like I made you do, there is a formula that if you know something, if you know at least 2 out of the 3 of these things, you can set up this problem. This is called corollary 1. The altitude is the geometric mean of segment 1 and segment 2. So if something's a geometric mean, put those across from each other. Segment 1 and segment 2 go across from each other. So this would be a way to set up a problem, and this is called corollary 1 of the right triangle altitude theorem. So here it is. If I see this situation, and I tell you this is an altitude, notice how the altitude is going to go here and here across from each other, and the two segments along this hypotenuse, because there's a right angle right here. I don't show it, but it is a right angle. You would multiply 14 times 3, get 42, and then square root that answer. So 6.5 is the geometric mean of 14 and 3. So what they're saying is the altitude is the geometric mean of the two segments on this hypotenuse. So that is called corollary 1. There is another corollary called corollary 2. Corollary 2 has to do with the legs, okay, and the closest segment to those legs. So it says the legs are the geometric mean of the adjacent piece of the hypotenuse that was formed by the altitude times the original hypotenuse. So basically, these three things go together, okay? The leg, the closest segment on the hypotenuse, and the whole hypotenuse. And then these three things can go together. It depends on what they give you and what you're looking for. Okay, so since we have two different legs, it just depends on what you're looking for. So you could call X leg 1 and Y leg 2. It doesn't matter. That's kind of how we did it here. We said leg 1, segment 1. So if this is leg 1, segment 1 is the closest segment to it. And then the whole hypotenuse is 15 plus 4, which is 19. So the legs this time, leg 1, which is X, is your geometric mean. So it goes across from each other like this, and then the 15 and then the whole side of 19 goes in the opposite diagonal from the 15. So over here, leg 2, which is the Y, notice how it goes across from each other. The closest segment is 4 and the whole hypotenuse is 19. Okay, so the leg is the geometric mean of the closest segment to it and the whole hypotenuse. Those two things have to get multiplied together to find these. Okay, so I'm going to let you work on these on your own. So there's 1, 2, 3, 4 to try. And then there's the next 6, so a total of 10. And then there's answers under here. So if you move it, you'll see answers. This is for you to practice on your own. Okay, so all I'm going to do is flip through here and see, did they try these problems? I want you to try it first before you go look at the answer. Also, remember what I said, sometimes it's just a Pythagorean theorem problem. So if you end up looking at 2 sides of a right triangle and you're looking for the third side, just plug it into Pythagorean theorem. But try to think about the formulas that I was talking about earlier. So you're going to want to write these down. So m is the altitude. If I know anything about m, it is going to be the geometric mean that goes across from itself. So sometimes I'm looking for it, or sometimes I might know it. So if it's an altitude problem, then the other 2 spots are the segment 1 and segment 2 along the hypotenuse. So this would be a corollary 1 problem. Okay, so that's one formula you can use. So it just depends on what they give you. Look, K and G and looking for M. And I see a K and a G and I'm looking for M. So this problem could be plugged into here. Okay, corollary 2. Well, let's say I'm looking at F. It's a leg on the original big triangle. F is closest to K on the hypotenuse. Okay, so F, your leg always goes in the geometric mean spots. The closest segment goes in one place, the whole hypotenuse, which would be H. So if you know K and G, you could add them together to get H. So this is one possibility, or the other possibility would be looking for E. So if I put E in the 2 spots, it's the closest segment on the hypotenuse and the whole hypotenuse. Now, sometimes you have to find things that they don't ask for in order to be able to plug into your formula. These 2 spots are thinking about turning all 3 triangles in the same direction. So USR. So if you turn this, or you could turn it to where the right triangle's in the bottom left, like we drew them, and then draw the other 2, you'll be able to fill these in easily. Okay? All right, so you're going to do the 10 problems. It's strictly practice. This is just going to be something easy for me to just flip through and see if you tried it. And then remember, the answers are here. Also, go back and look and see in this 6 weeks if you have anything that you owe me, and look at that redo opportunity and let me know if there's something that I haven't graded or that I need to grade.